Hi,
Amazing. Yeah,
welcome
I can see your
everyone.
screen.
Okay, cool. So my name is James Serra. I'm a data and I solution engineer at Microsoft. I recently moved over to a new account team where I deal with Japanese global accounts like Hyundai and Toyota. And for these customers and many, my history has been in this particular topic of helping them understand the various different types of architectures there are, and in particular we'll talk about a modern data warehouse, a data fabric, data lakehouse, and a data mesh. Feel free to drop questions in the chat along the way. I'll go about an hour in the presentation and then I'll take your questions. I may stop along the way to answer some of the questions in the chat. I'll pay attention to it as we go. I've been around quite a long time. I won't go back to my COBOL days, but for the last 12 years almost, I've been at Microsoft and has been mostly focused on pre-sales, where I spend my time educating customers. And the products of choice lately have been Microsoft Fabric and Microsoft Purview, and I'll cover those today because the idea of this session is to level set and make you understand the four different types of architectures, and then get into how Microsoft Fabric can be used for those different architectures on there. I have to say these are my opinions, not that of Microsoft. So I may come up with a description of a architecture, a concept that not everybody at Microsoft may agree with. Most may, but Microsoft doesn't have an official stance on really all of these things. There's no official Microsoft word. So everything here is James Serra's word. And for those that stay to the end of the session, I wrote a book on data architectures, and I'll talk about a way you can get the book for free at the end of the presentation. I find a lot of people get confused about data architectures, and it may look easy, but you may find out that it's like opening up a box and finding hundreds of parts and a terrible instructions on there. So I'm going to try to prevent you from feeling like this by making you understand these architectures. And if you're in a role in your job that is going to build some data warehouse or data warehouse like solution, hopefully this will clear things up for you. So a relational data warehouse in there, I think most people know what this is, but just to level set, the idea of creating a relational data warehouse is to take all these data from multiple transactional systems or OLTP systems and copy it into a data warehouse where you'll make analytical data out of this. And this will be your central repository that has all this data and becomes the single source of the single version of the truth on there. The data warehouse is not an OLTP for OLTP applications. It's a write once, read many to do reporting on that. The reasons you would use a relational data warehouse are many. Just to hit a few of them is to have that single version of the truth, as opposed to people are sending out Excel spreadsheets. We call it spread marts, and each of those spread marts is hitting a different source system, and you may get different answers to the same question on there. So a consolidated relational data warehouse prevents that. It also reduces on the production stress on the production system. If you have a reporting system, a CRM system or ERP system, or some homegrown solution that you built, some OLTP solution, and it's doing reporting, think of it as maybe you have a bunch of customers and you want to run some sophisticated report that's going to run on that source system, that OLTP system, and generate this customer report. Well, if somebody sends along a query that's malformed, it produces a lot of stress on the system. Meanwhile, you have people on there trying to do updates, deletes, and inserts are not able to do it because all these reports are running and overwhelming the compute capacity. So the idea is the data warehouse will do all those reporting and leave the OLTP system, that transactional system, to do the entry of the customers. Also, you want to get to the last bullet point here, do self-service BI. And one way to do that is to make it really easy for that end user to run reports. And a way you can greatly help them out is to rename tables and fields. If they go against a source system, especially say a ERP system that's been around for years, they may have very cryptic columns and table names, T116, and the end user may not understand what that is. Well, as you create this relational data warehouse and copy the data over, you don't just copy the tables as is. You create a data model and you rename the tables and fields to be more descriptive. So you would call it customer. And this way it allows that end user to be able to quickly and easily create those reports without getting IT involved. You may have traditionally seen relational database data warehouses in tools like SQL Server or Azure SQL Database. We're getting away from that. There are use cases when you still may want to use those when I'll talk about it, but the majority of times you're going to use another product like Microsoft Fabric for that. But keep in mind a relational data warehouse has relational storage, and this is something we're getting away from that I'll talk about. Now we also have a data lake, and this became quite popular, I want to say 10 years ago. And this is very different than relational storage in that a data lake is what's called schema on read. You don't have to do any upfront work to land data in there. That means I could put any source of data, not just relational data, but I could have media files, video files, JSON, Parquet, CSV, can all be dumped in a data lake on there. And that provides its own challenges, which I'll talk through, but this opens up a lot of reasons why a data lake can be very useful. And a data lake, if you look at the Microsoft world, traditionally was in an Azure Data Lake Store Gen 2. And then now with Microsoft Fabric, a data lake is in what's called OneLake, which underneath the covers is Data Lake Store Gen 2, but it has a lot more functionality than just being storage. The reasons why you would use a data lake are numerous also. The biggest one is if you think about having a relational storage and you're loading all these source systems in there, typically, because that's compute intensive to load data and then clean it, you have a maintenance window at night. So you kick people off, say at 8 p.m., you start loading all the data in, cleaning it, and then you cross your fingers that everything goes fine, and then you open up that maintenance window so people can jump on and start using it. The trouble with that is, one is if you want to have a 24/7 data warehouse, you're kind of out of luck. And number two is you can run into issues with the maintenance window not being able to do everything. Maybe there's so many data sources now that you have to say no to some of them because you just don't have a long enough maintenance window anymore. So the data lake, what it's best used for is to offload that transforming and cleaning of the data. So instead of having a maintenance window where the relational storage is doing everything, you take that process and you have it done in a data lake. So the data is copied from a source into a data lake. Data lake just storage. So you put compute on top of that and it does all the transformations and then stores it back in the data lake. So you don't have to have a maintenance window with your relational storage other than maybe a few minutes when it's loading the data, but all that cleaning is done outside of that. So you can have a small to no maintenance window and run it 24/7. And you also have the benefits of having a bigger compute to clean the data than you may have available in your relational data warehouse in there. And also the data lake is extremely cheap, especially compared to relational storage. So you can stockpile data in there. Where a relational storage data warehouse, you typically wouldn't do that because it's costly and you have a limited amount of storage. Where a data lake is unlimited in the cloud in there. So you can put data in there if you're not even sure if it's useful. Just throw it in the data lake, and we down the road we can see if it's useful. All right, so we have the relational data warehouse, and then the data lake. The modern data warehouse architecture that came around, I would say it's right after a data lake came out, so maybe a dozen years ago, and the modern data warehouse is made up of both using both a data lake and a relational data warehouse, and kind of using the best of both, which I'll talk about in there. Any architecture you built will generally have 5 steps. You're going to ingest, store, transform, model, and visualize the data. All the architectures I'll talk about, that still applies. Most architects have these same steps. They may call them something different, but the idea is still the same. It's moving this data into in the end, a model of the data in such a way that an end user can easily visualize the data, create their reports. So there is the complexity and the cost of doing multiple transformations with the data as it moves along into the final model version in there. New tools allow you to reduce the number of copies, but it's still a lot of work. You're still going to have multiple copies of the data. The benefit is that it's self-service BI. So you'll have a copy of the data in a modern data warehouse or MDW architecture in both a data lake and a relational data warehouse. This is going away in the later architectures, but it's good in historical context to understand that you have 2 data stores in the MDW. And the reason you have 2 data stores is the data lake can't do everything. It has challenges with trying to do everything listed on here, and the same thing with a relational data warehouse in there. One being with cleaning of the data. So the idea is, let's have each of these technologies do what it's really good at. The data lake is really good at staging and prepping the data, and the relational data warehouse is really good at serving, putting security on the data and compliance with the data on there. And if we look at the staging and prep, it's also possible to land something in a data lake and get a report out of it really quick for one-time use, as opposed to having to move it onto the relational data warehouse on there. It's great for data scientists who are fine with the data in a data lake, even though it can be hard to understand. They usually have a technical background and they could make sense of it. It's also good for exploring, where you can put data in there. It's cheap, and you can start looking through the data, because maybe you don't know how you can use this data. You don't know what questions to ask yet. And so you can play with the data. And then when you find the questions asked, you can, and the data is useful, you copy it into the relational data warehouse, where you can set up those dashboards and reporting. And also that you have the security that doesn't exist in the data, things like roll-up security on there. Again, this is changing, but traditionally the data lake was very limited on its functionality in there. So instead of trying to mock up something in a data lake, you instead could use the relational data warehouse, where for many years it's been very good at the security aspect of it. So what this looks like at a high level, the architecture of a modern data warehouse is this: there are those 5 steps, and then you have this data lake, which is divided up into different layers in there. You may have heard the medallion architecture. We have this bronze, silver, gold. I like to call it the raw, clean, then presentation layer on there. And the idea being that the data is going to land in the raw format as is from the source system, but needs to be cleaned, and you would do that, transform it, and put it into the clean layer, or some people call it the enriched layer. You may further do things to it. You may join in, aggregate it, master it, and then put it into the presentation layer, the gold layer, to make it ready for the end user to use. That may be fine at that point for, say, like a data science to use in a presentation later, but because of the previous slides' benefits of a relational data storage or warehouse, is you would copy that data into a relational storage, where it may first land in third normal form, and then it may use a star schema, if you're familiar with that. And that is, again, putting it in a format that makes it really easy for the end user to do the final step, which is the visualize of the data. And this has traditionally been done for those who've been using Synapse. Synapse uses the modern data warehouse architecture. It has both a data lake, which is Data Lake Store Gen 2, and then the relational storage was a dedicated SQL pool. Synapse is not gone away, but is going away. There may be 10 years, but Fabric is the new way of doing things. And we'll talk about the architecture that Fabric uses, but Synapse has traditionally used this modern data warehouse approach. All right, so that's the first one. The next one, that the architecture, is the data fabric. And this is where my definition may be different than others in there. I view as data fabric as an evolution of the modern data warehouse, where over the past 7, 8 years, we've greatly made available different data sources that are more complex to use. Things like JSON format or Parquet format or streaming data. And so a data fabric architecture was created in order to handle this different types of data in there. So it adds a lot of features to a modern data warehouse in there. Things like real-time processing. It may have additional security. It may have a metadata catalog like Purview with it. It may master the data. It may have a virtualization layer in there. So all these things that are added to a modern data warehouse make it a data fabric in there. Now, a lot of people have just replaced the term modern data warehouse with data fabric on there, and so you can think of a modern data warehouse as an older version of a data fabric, so a data fabric can handle that additional data and make it more secure. The way a data fabric looks at a high level is we add additional features in purple here. The metadata, master data management, additional security. You may even have APIs as a way to pull the data, to request the data from the storage as opposed to a connection string. So a lot of times customers will create a sophisticated API layer that end users can use, or reporting tools can use to pull the metadata and the data over. Digging down a little bit more into the data architecture, the data fabric architecture is this. So it's same steps, those 5 steps in there, but a lot of additional functionality in there. So you can see things like a Microsoft Purview on here and additional security that can be put on here. Again, this was Synapse. Synapse has the ability to ingest real-time data on there. It has Microsoft Purview built in. So most customers, until Fabric came around, until Microsoft Fabric came around, were using Azure Synapse Analytics for it. All right, so that's 2 of the architectures. Feel free to ask questions in the chat. I hope everybody can access the chat. So let me know if you're not, through coming off mute, and ask questions that way. But otherwise, just put them in the chat. So the third is a data lakehouse, and let's go through a little bit of history of how we got here, so it'll make you understand what a data lakehouse is better. Back in the day, in the 80s, when I was coding in COBOL, we had data warehouse in there. And back then, there was a Teradata, later Netezza, and those were all encompassing systems, meaning if you had Teradata, they had relational storage, it had the compute, it had the reporting system, and it had the ETL, all in one solution on there. And that worked great back then. Of course, big data back then was maybe a handful of megabytes, and customers would create data marts. You may remember the arguments we had shortly after this on Kimball or Inman methodology. Do we use data marts on there? And that solution worked very well until we got into the late 2000s. And the reason is the internet came around and provided a lot more types of data out there. So it was streaming data, it was social media data. It was just the fact people could all go on an internet site and enter data and create this huge database on there. And your Teradata and the Teasas couldn't handle that amount of data. So a data lake came around, and it was promoted as you can do everything with a data lake. You don't even need data warehouses anymore, and relational storage anymore. And Hadoop, which was such a big thing back then, and Spark were the go-to solutions to build these data lakes in. That in effect became your enterprise data warehouse in there. Well, that failed miserably. The reason was the technology was complicated to use, and projects I saw just failed miserably when people, especially if they tried to replace their relational data warehouses with a data lake in there. However, what came out of that was, hey, let's not throw away a data lake. Let's instead use it for what it was good at and try not to use it for everything. And hence the modern data warehouse came out, where we said, let's use the data lake for cleaning the data because that's what it's good at, and we'll have the enterprise data warehouse still do a lot of things. And we came out the modern data warehouse and then the data fabric. And that worked well, still works well. But what came out in 2020 through Databricks was this data lakehouse concept, was combining a data lake and a data warehouse into a cute term called data lakehouse, where you don't have relational storage anymore. You put everything in a data lake. And you should be saying, wait a minute, you just said that failed. Why are they doing it? Why were they doing it again? And the big change was a new technology called Delta Lake. And Delta Lake was this layer, a transactional storage layer that was built on top of a data lake to give that data lake relational data warehouse like features. So it wasn't its own storage, it was just sophisticated code that allowed the Delta Lake to have enough new features that, especially when it first came out, at certain use cases, I said, well, yeah, I can actually see not having to use a relational data warehouse in there. At first, I thought it was very limited, but the technology has grown to just about every use case now can get away with not having a relational storage anymore and just using Delta Lake in there. The Delta Lake, through that software layer, gave the data lake some features that didn't exist, such as SQL commands. If you had a regular data lake, it didn't know anything about what SQL was. And so so it made it harder to transact with that. You had to go into Spark and load the table, and that was complicated. And that's why it failed, because it was too complicated for most end users to use when they had a relational data warehouse that was so easy through SQL. And so Delta Lake provided the ability to just do any of this SQL commands, and it would know what you're talking about and would modify or query and pull out the data in the data lake in there. It supports time travel. As data's landing in the data lake behind the scenes, it's versioning it. So you can do time travel. You can say, give me the data as it was last month in there. And it also had a lot of performance improvements on there. A big challenge with a data lake when you're trying to pull out the data was it could be very slow. And that's also why a data lake failed, was it was just way slower than a relational data warehouse in there. And so Delta Lake gave a lot of performance improvements to do that. There are competing technologies like Apache Hudi and Iceberg on there. Microsoft has standardized in Delta Lake, so that's why I talk about that. But the technology has come out now that you can mix and match all three of these somewhat, and more in the future. So you're not having to lock into one particular approach. If we look at the data lakehouse high-level architecture, you'll notice it's just like the data fabric, except under model, we don't have a relational storage anymore, because everything is stored in a data lake using Delta format. So we call it Delta Lake. Underneath the covers, it's using Delta format, which means it stores everything in Parquet format. Microsoft Fabric, using that product, will hide all that from you. It'll just store everything in what I mentioned before is called OneLake in Delta format in there, but that's not really relevant to the end user. They don't care how it's stored. They just want to use it. And so underneath the covers, it's complicated, but how it's presented is very easy to use. And this is kind of, the first question was a relational database component in the Fabric ecosystem. There is a relational, or there is a warehouse, but it doesn't use relational storage. It uses the Delta format on there. So it appears that it's relational storage to the end user. They may think it is, but it's really using the Delta format. And that'll come out a lot more when I get to the Fabric section in here. And then another question is, would you define data lakehouse as data lake plus compute on there? Yes. The data lake is just storage in there. So if you add compute on top of that, that would be part of the data lakehouse. And you can kind of see it here. We have this transform piece, and in the slide, you'll see the compute comes on top of that. So part of a data lakehouse is having mandatory to have a data lake and the compute on top of it. So having a data lakehouse helps these 6 problems that you see in a modern data warehouse, where you have both a data lake and a relational data warehouse in there. And just point out a couple of them is you have 2 copies of the data, so you have to keep them consistent. So the data lands in a data lake and then it goes over into the data warehouse. Well, what happens if the ETL has a problem? You now have data that may be wrong in the data warehouse. And so the end user, depending on what their query, they may get different answers. Also, the data warehouse is going to be updated from the data lake. It may be updated once a day, maybe every hour, but there's going to be some lag. And that could be a problem because, again, end users can get different answers depending on which source they go to. And then if you have those 2 very different types of technologies, you have to get people that know both those technologies or people who are experts in one or the other. And so that's more complexity. Get rid of the relational data warehouse in there and that relational storage, and you don't have to get so much skill set. Diving a little bit more into this architecture, this is what it looks like. It's, again, very much like the data fabric architecture, except if you see the relational serving layer, there's no storage. It is think of it as like a view, a SQL view on top of the data. So it looks like relational, but it's really pointing to data that's sitting in the presentation layer of the data lake. This is what Microsoft Fabric is based on. I'll dive more into this shortly, but Microsoft Fabric by default has a data lakehouse architecture on there. There is no relational storage in there. The concerns about skipping a relational data warehouse or relational data storage in here is that there's a lot of a handful, I would say, and the few I'll point out here is if I don't have a relational data warehouse, which underneath the covers uses relational storage, which has been improved for many decades to be very efficient, very fast. It has things like massive parallel processing or advanced indexing and statistics and caches and query plans, and those who are SQL DBAs like I was will know about these, and joining optimizations and materialized views. None of those exist in the data lake or a Delta lake. And so a Delta lake is never going to be as fast as a relational data warehouse. But then it becomes too fast enough. With Delta Lake having a lot of improvements, you can get pretty close to the speed. And so this problem tends to go away, along with most of these problems tend to go away if you're using Fabric and Power BI, because it has workarounds or comes up with other methods for eliminating these concerns. Like the second one, there's Delta Lake does not have any roll-up security, column-up security, dynamic data masking. However, those features are in Fabric and Power BI. So while Delta Lake doesn't do it, you can do the same thing if you're using Fabric on there. And the challenge with a Delta Lake is that you're in a file-based world. It's folders and files in there. And the metadata may not be within the file. So think of a relational data warehouse. If you're going to create a table, you got to create the table, the fields, a schema. You have to have all the metadata in place, no exceptions before you copy the data in there. In a data lake, one of the trade-offs is that I can land a CSV file in there, and it may not have metadata in it. Maybe the metadata is separate, or maybe the metadata doesn't even exist at all on that, and that could be a big challenge. New technology like Delta format has the ability to define a schema to prevent invalid data being there, but it's not required in there. So this could be a challenge getting away from a relational storage in there. However, Fabric once again comes to the rescue by forcing you to have metadata on top of the data that's sitting in a data lake in there, and we'll talk more about that. All right. Don't see any questions. So let's jump to the fourth architecture, and that is data mesh. Data mesh, which has been around, Zamak had a blog post almost 7 years ago now. Wow, time is flying. That introduced the idea of a data mesh, which wasn't new concepts. They were just packaged together really nicely. And it was very difficult to understand. And hence one of the reasons I wrote my book was to try to make it easier for people to figure out exactly what a data mesh is. And this slide hopefully will make it easier to understand. The three architectures I talked about, they all combined the data in a centralized location. So took operational data, copied into a central data warehouse or a Delta Lake, and created the analytical data on there. A data mesh is decentralized, meaning there is no copying the operational data into a central location. Instead, each domain, which could be, say, HR or finance, they are the ones that are taking operational data and converting it to analytical data in their own domain. And then they provide a way for other domains to use that data. So that's what it means by decentralized. All the data remains local. You're still creating analytical data. You're just doing it within each domain. Now that could, for those who've been around a long time, could immediately trigger problems that could arise out of that. And that's what's happened. And data mesh is not nearly talked about as much anymore. It still has a use, which I'll mention, but it's because of the challenges of decentralizing things, it's just not something that is extremely popular in there. And it's important to understand the data mesh is a concept. It's not a technology. And it requires a huge organizational shift, which is a reason why a lot of companies have not gone down that path of data mesh, because people don't like change to begin with. A data mesh, to try to simplify it also, is made up of 4 principles on there. And a principle number 1 is domain ownership, meaning each of those domains own the data instead of copying it in a central location where IT would own it, which was always an argument, who owns the data. That goes away because the domains own that operational and analytical data, and you set up these domains, which that can require a lot of change right there, but that's required in data mesh, is to have all these domains. And then each domain treats data as a product, meaning they are going to have the infrastructure and maybe write some APIs that are going to create the analytical data from the operational data and then make it easily available for others, hence that term data as a product. on there, they have to do some work. So it's very easy for others outside of their domain to use the metadata and their data. And so each domain is going to have their own teams, like a mini IT team that's going to do all that work to make it available for everybody else to use. Well, that could be a lot of work. And if you have dozens and not hundreds of domains, you don't want them all building everything from scratch. That's where principles 3 and 4 come into play. The idea with 3, self-service data infrastructure as a platinum, is to make it easy for each domain to build their analytical solution on there. And yeah, ideally you have a script and you enter your domain name and it builds everything for you, and which includes storage and the compute and the ETL and the security. But the reality is it only do a little bit of it. So most customers are building their own scripts to do all this. The products out there like Fabric can help in some ways in there, but it's very limited on there. And then 4 is federated computational governance, which means if we have all these domains building their own analytical solution, they could be having different rules for cleaning the data. They could have different ways of making it secure. So we've got to come up with some playbook for them to use, some global rules for each of them to use. And that's what 4 is to provide those rules that on how each domain should handle data quality or security or modeling the data on that. And so this is the data mesh in theory, is you've got to follow these 4 principles in there. So this solves some of the problems with your centralized approach. The 2 biggest things it solves is scaling. If I have a centralized approach, I have a limited number of people, they could be bottlenecked on improving and then collecting data on there. And that goes away with a data mesh, because the idea is you have domains, and the more domains you have, they have their own IT team. So the more domains, the more people you have. And so you're scaling out horizontally, and you solve that bottleneck of people. And the same goes with technology. Instead of having a central location where all the data is using one central platform, which could be overloaded, each domain has their own infrastructure. So more domains, more infrastructure, and you have to have technical scaling on that. That's the idea of that. Now, where data mesh gets complicated is people won't follow those 4 principles. Maybe they follow 3 of them. And so should you even still call it a data mesh? Some customers will follow 2 of them partially. They still want to call it data mesh because it's a cool term, but reality is that they're really following like a data lakehouse approach on there. Maybe they're just using data as a product and calling it a data mesh, but it's really not a data mesh. And the big challenge with a data mesh is creating these domains, and this could take forever. And that's why a lot of customers have not gone down there, because it requires defining the domains and then moving people around into those domains. So there's a lot of concerns with a data mesh. My book covers them. I could have wrote a whole book just on the concerns in there. Just touch on a few of there. People don't like change. So to build it out of data mesh is going to take much longer than build it using the other architecture. So people push back because of that. It's hard enough getting quality people in IT, but now you're going to have each domain hire their own IT team. That could be very challenging to get a good people to help out with that. And if you now tell each domain, hey, you have to, instead of giving your operational data to IT to make the analytical data, you're telling them they have to do it. And they may go, well, why should I do it? We can barely keep things running. Now you want us to create our own data warehouses. And so what's their incentive? If you just say for the greater good, that's probably not going to go far in there. So you need incentives, and that's where another customers get challenged. And then if each domain is building their own analytical data, their own data warehouse in there, they are not really paying attention to how it could be used outside of it. So if there's nobody kind of big picture how we can combine all this data, which is going to happen, you may have solutions built by each domain, which make it extremely challenging to combine all the data. Where if IT is handling all the data, they're doing that by default. So while data mesh has not gotten very popular, I see kind of hybrids of that. What I list here is some customers, they will have built a centralized solution like a data lakehouse, and they may have new types of data that they decide they're going to make a data mesh and so they may have a couple of points that are data mesh, a domain on there, combining that with the centralized data. Now, maybe over time they move some of the centralized data into domains as a data mesh, but most customers have a hybrid approach. And for IT, you may be happy because you're like, well, hey, at least a couple of these domains are not falling on us to incorporate all this new data. We're having them do the work before we take and combine it with others in there. So the four domains, the four architectures, if you look at when they're used, a modern data warehouse, very rarely used anymore. Maybe if you have small amounts of data, you can have this data lake and relational storage in there. If you have such a small amount of data, you can even say, well, actually, we don't even need a data lake. We'll just put everything in some relational storage in there. I always hesitate when I hear customers say that because I may say now you don't have a lot of data, but what about in the future? And if all of a sudden you have all this other real mass amounts of data, you may be overwhelmed and not be able to support it. A data fabric, that evolution of modern data warehouse, also don't see much anymore because of data lakehouse in there. But I do see it for customers trying to migrate from, say, a large on-prem data warehouse that was all relational. It could be easier to migrate that into a data fabric that has the relational component because it minimizes the amount of effort to migrate everything over, because a relational data warehouse in the cloud could be exactly what you have on-prem, and you could have thousands of stored procedures that don't need much, if any, changes, where if you're going into a lakehouse and using Delta format, it could result in a lot of modification that need to be done. So data lakehouse, I always tell customers, use it until you can't. And then if there's a particular piece of a set of data that doesn't work, maybe you don't get the performance you need, then you could just take that subset of data and copy it into some relational data warehouse on there, but everything else would be in a data lakehouse approach in there. But because Fabric has really progressed, I rarely see it not being able to be performant enough. And then finally, a data mesh architecture is just if you're even consider it, if you have a very large company, you have a lot of pain points, you're already domain oriented. I see this a lot with banks, financial companies, then maybe you could afford the drastic change in a long timeline and get the benefits of a mesh. All right. So let's now jump into data architecture in Microsoft Fabric. We had a question: when you step into a file-based thinking of some aspects of DDD, then it becomes more practical and AI friendly. Yeah. Thanks. There's some nice comments in there. AI friendly, is your data AI ready? I just blogged about that, and that'll be something that I may add to this in the future. But for right now, I kind of stay away from the AI ready component of that. So let's jump into another question. Building a centralized observability to monitor data exchange and data mesh would be important. Yeah, amen to that. There's a lot of monitoring that needs to be done. I think Zamek made it seem like it's easier because he just kind of said you can just automate everything. But in reality, there's no products that can automate everything. And so you really have to do a lot of monitoring of the data, because you can wind up having data going all over the place, multiple copies from a source system. All these domains can decide, I need the customer data, and they just grab it. And that becomes challenging. You need monitoring of the security. Oh, I gave you a playbook to follow, but how do I know you're following that? I mean, you need a centralized team that's going to monitor all that. So a lot of that comes into play. Otherwise, you wind up having the problem that happened many years ago when customers went to data marts was you had all these siloed data marts happening in there and doing their own thing, and security breaches happen and all that. So a lot of monitoring has to happen. So looking at Microsoft Fabric, it's important to understand there's two ways of building data mart or data storage in Fabric. One is you can have a lakehouse. The other is you can have a warehouse. A lakehouse and lakehouse tables are, if you're the data engineering type, if you like using Spark, then you would use a lakehouse because only with the Lakehouse can you write with Spark. If you wanted to use T-SQL to write data, that would be where the warehouse table is coming in. If you're used to data warehousing, if you're used to using T-SQL, then you would want to create a warehouse for storing your data, not a lakehouse. Now, both T-SQL and Spark can read from lakehouses and warehouses, but it's important to know if you want to do any writing, inserting, updating in T-SQL, the data would have to be in a warehouse. And if you wanted to do in Spark, inserting up and deleting, and it's got to be in a lakehouse. That's the biggest difference between the two. So you really have to understand that. I have a whole video on this, and I'll make these slides available that go through in detail of the difference between the two. The architecture Microsoft supports is modern data warehouse. It's yes, it can technically support that by the use of a warehouse and a lakehouse, but this is where it's all been a gray area. The warehouse is not using relational storage, it's using Delta format. So you could say that a modern data warehouse is not possible in Fabric on there. I just say it is in theory because you could have two things that are separate, a lakehouse and a warehouse that you have to keep up to date, just like you do in a modern data warehouse in there. Because a lot of customers, they may land data in a lakehouse, do the cleaning, and then copy it into a warehouse to make it available for others on that. And which could be because others like a relational data warehouse front, and a warehouse you build in Fabric is easier to use for those people who are relational data warehouse minded. Data Fabric, again, is the evolution of modern data warehouse. So it's the same thing, except you can use, with a Fabric, you use, say, real-time streaming, and Fabric supports that because of real-time intelligence, and which is a streaming component of that. And that could be the deciding, what could be the deciding factor in using the warehouse is if, again, you're migrating from something, say, on-prem. If you migrate it to a warehouse, there's less having to rewrite store procedures than if you were migrating to a lakehouse. So the third architecture, a data lakehouse, that's the default in Microsoft Fabric. And if there's a rare case where you can't get the performance you need, maybe you have billions of rows, in Fabric, you can put that data in an event house, or even now Cosmos DB, to query against to get the performance you need. It's very rare I see this, but it is an option. And then you can build the data mesh in Fabric. There are exceptions to that, which we'll talk about. But if you want to go that mesh route, you can do it in Fabric. And a data lakehouse, if I take that architecture I showed before and put all the Fabric pieces on it, this is what it is in there. So you can see for things like the data lake, the compute you can use, there's multiple options. There's Dataflow Gen 2. It's kind of like a no-code way of transforming data. You can use a Spark notebook. You can create a T-SQL procedure if you want on there. There's a lot of flexibility in Fabric. Fabric is just a combination of many different products, and that gives you a lot of choice in how you want to build things out. And then when we look at the relational server layer, that's a semantic model. It's the equivalent of like a SQL view that Fabric has. So the data is made easy to understand by an end user, because you're not saying, hey, here's a bunch of files and the folders in there. Instead, you're presenting them with a semantic model, which looks like a relational database, but it's really pointing the data sitting not in relational storage, but in Delta format in OneLake. Microsoft Fabric does have the support of domains on here, so I can go in there and I could create workspaces and then create a domain that allows you to put those workspaces in those domains. So I could have say an HR domain, and in an HR domain has a bunch of workspaces, and that's my domain. Now, what's challenging about that is there's nothing that says you have to follow the 4 principles of create a domain. I can create a domain that actually it's called HR, but it could have marketing data in there. So there's a lot of best practices you have to follow to make sure you're going along that data mesh route if you want it in there, because there's nothing that's built in for that. And so there's a lot of data mesh exceptions if you're using Microsoft Fabric. One of them is that you're required to use Microsoft Fabric instead of my words are stumbling. In data mesh, in theory, each domain can use whatever technology it wants, but that's going to be extremely challenging. Think of trying to have everybody use the same security, but now everybody's using, when somebody's using Google Cloud, AWS, and Azure Cloud in there, and then even within Azure Cloud, imagine people are using different technologies for building out their analytical solution. Some are using Fabric, some are using Synapse, some are using Cosmos DB. It's just too much on there. So most customers will standardize on Fabric being the technology each domain is going to use. They won't build APIs until they use which Fabric shortcuts on there, and there's other things that I won't get into, but there's a lot of links if you want to look more into the exceptions. But bottom line is you can build a data mesh in Fabric, but most customers are not following all 4 principles. They're following maybe 2.5 principles, maybe sometimes not even 2, and they want to call it a data mesh, and Fabric can work for them, but it's kind of limited in supporting a complete ideal data mesh. You want to think of Fabric as this great unifier, because whether I'm using a Lakehouse or a data mesh, it can make it very easily to combine the data from multiple sources without having to all land it in one central location. So think of a data mesh as if I have all these different domains and each domain is using OneLake storage, I could have another workspace that has its own OneLake storage, but is also combining all the other data through shortcuts. So I don't have to combine it all into one location. It could just use shortcuts and pull it over as needed. So this is a great way to support the data mesh architecture, but really data lakehouse can work great because you don't have to put everything in one lake. I could build a solution in Fabric that is using one lake and having a bunch of local data, but maybe other people have put data in Amazon S3. Other people have other one lakes that they've created, and I could just have shortcuts to all of them instead of trying to load everything into one central location. And this is kind of a virtualization layer that typically would require virtualization products anymore, but this is all built into Fabric. So it can make it very easy for end users to build a solution that can be a combination of data in other locations, Snowflake or Databricks, and not have to do a lot of copying. All right. I wanted to mention it's called Mac2G. This is Microsoft's I'll call it a package system that Microsoft has where you can hire Microsoft's consulting services to build a solution for you, or you can go out and read about Microsoft's approach to building a solution no matter which architecture you're going to use on there. So there's an ebook available to that. There's a couple of links here, especially the Cloud Scale Analytics, that gets into not just technology, but the people that you want to hire. My book goes through this too, but there's some great resources out there that Microsoft has built through their own knowledge they've gained with many different many different solutions they built for dozens or if not hundreds of customers in there. So definitely check out this Mag2G if you're going to go down the route of building a warehouse solution, no matter which architecture you're using. All right, let's see if we have a question. Yeah, thanks. Looks like we just got comment. Oh, one of them. Where does the semantic model stored? In Fabric, you create a semantic model, and then that semantic model, you create you define all the tables you want to use, and the relationship between those. It's your typical relational model, and each table will be pointing to a file sitting in Delta format in the one lake in there. So the semantic model is just an overlay, and that is all stored in Fabric. So when you go to Fabric dashboard, you'll see a semantic model on there. And then you can open it up in the model view and you can see the tables, and then you can click at each table and you can see where it's pulling the data from. All right, thanks. Roswan asks, Lakehouse or warehouse for the silver layer in Fabric? Oh, so that was a slide I didn't go over. It was a hidden slide on here because of time constraints on there. But this is where I will see most customers will use a Lakehouse for the bronze or raw layer. Because they like using Spark. They will also use, well, because they're cleaning the data. I said if you're going to clean the data in Spark, you have to use a Lakehouse. So they will use the Lakehouse for clean layer. However, in the gold layer, often they will use a warehouse as a presentation layer because it's more relational data warehouse like and easier for end users to use the data. Now you can mix and match these. You could have everything Lakehouse, everything warehouse. You could even have in the gold layer a copy of the data, some in the Lakehouse and some are in a warehouse, and that. It's all the way you want to present it to other people. And maybe a data scientist comes along and says, you have all this data in the warehouse, but I want it in the Lakehouse. And you say, okay, I'll copy the data over. And they're more to maintain, but you're making more people happy with that. Instead of having them go and do the work in IT, you can create that warehouse for them. Now, I'm talking about coding and using T-SQL and Spark, but also, and I didn't mention this, and this here is, I could use data pipelines or data flow Gen 2 to write data no matter whether in a Lakehouse or a warehouse. So if I choose a Lakehouse, that doesn't mean I have to do everything in Spark. I could, in addition to using things in Spark, I could use a data pipeline or data flow Gen 2 on that data also in there. So those approaches do support writing to it. But if you're going to get into T-SQL, and you'll find out usually the hard way, I create a Lakehouse, I go into Fabric, I go into the query editor, and I'm trying to write T-SQL, I create table, and it says not allowed. And it's not very, the error message is not really good at telling you why, but you'll go like, why doesn't this work? And you go like, oh, I'm using T-SQL, an insert update on something that's in the Lakehouse, and it's not going to allow you to do that. If you do it on the warehouse, though, it can. All right. So any more questions? Pop them in the chat. Let's see. 2 layers or 3 or more in the medallion architecture. Hey, another fantastic question. So I've been showing 3 layers in here, and that's generally the way people go. 3 layers, gold, silver, bronze, raw, clean, presentation, whatever you want to call them. However, I've seen customers with as few as 2. I've seen customers with 7 or 8 layers in there. Medallion architecture traditionally is 3, but you could have a titanic or titanium layer if you want, whatever you want to call it in there. Data lake design is a long conversation I have with customers in there, because you have to think through the layers you're going to have and then the folder structure you're going to have within them. And typically the folder structure is different, whether you're in the raw layer or the clean or presentation layer on that. So with a lot of customers, we'll do an architect design session and we'll talk about data lake design. And I will go through all the source systems that they have now and in the future and come up with this design that could support all those, no matter whatever the size, speed, or type is in there. We have another layer listed here. If you're going to master the data, that may be another layer or maybe another folder structure within, say, the clean layer on there. So there's no way you have to do it. And it's always different on the customer. They're always going to have, at the very least, different folder structures, if not different layers on there. So you really want to spend some time thinking about that, because the last thing you want to do is create a data lake and you're using Delta format in there, and you design it and then it works until a few months in when somebody comes along with maybe streaming and you go like, oh, I never thought about using streaming, and our data lake, the way it's designed, is not going to work, and then we have to go and re-architect it out and move things around. It's really a pain in the neck. So think through a lot about data lake design. Think through your architectures in there. So I presented 4 architectures. Most customers will use a little bit about each. So that's why it's good to learn about all those architectures, even if you go, that data mesh, there's no way we're going to do something like that. But I do like that idea of data as a product. So I'm going to build a data lake house, but I'm going to use data as a product, which could be your semantic model is required and follows certain rules. So you're creating data as a product, and it makes it easy for everybody else to use it, especially if you start using shortcuts and pointing to other one lakes. If they have a nice semantic model, it will make it a lot easier to use and combine it with other data. So that data as a product concept is the most popular thing that has come out of a data mesh. So most people don't use the other principles, but they like that data as a product principle. All right, Victor asks, Dataflow Gen 2 costs more than Spark Notebooks and Fabric. That is why a better use of Spark. That consulting answer, it depends on there. I've seen Spark be more expensive and vice versa on there. A lot of it depends on the skill set of the people writing the code in there. In Fabric, most decisions are made not on cost, but on the skill set. If you are really good at using Spark, I would say go and write Spark notebooks because you're going to write something efficient. If I ask you if you know Spark and you give me a blank stare, I'm going to say maybe you want to go down the Dataflow Gen 2 path and visually build solutions out to transform your data. And that, no matter what the cost is, that could be more cost effective to build a solution in what you know best. If you find you built something in Dataflow and you're like, wow, this is really expensive, and I don't really see a way of rewriting or moving things around in Dataflow Gen 2, then that maybe that one particular job could be done and rewritten in Spark Notebooks in there. Spark Notebooks will generally give you a better performance, but that only applies in specific use cases in there. There's a whole blog post I've seen. I don't remember, I don't have it, I forgot who wrote it, but it's out there that goes into detail about the cost for different technologies in there. So you want to kind of review that. All right. So we're a little bit over my hour, and I said questions and keep them coming. For those that have stayed this whole time, I mentioned a free, getting my book for free. So this is as easy as just sending me an email. Say you attended the course or the session and you want a free PDF copy of that, and I'll send that to you. And then I do this all the time, and so happy to give you a free copy of the book on there. If you want to order it and want a hard copy, I don't have those to give out, but maybe you can have both the PDF and the hard copy if you want. The book will go much more detail of what I talked about on there. It also talks a lot about concepts like ETL versus ELT and what do you mean by master data management and data marts on there. Because I found a lot of customers, when I first started talking about data architectures, they were not very familiar with some of the concepts or the confusion. Hence, the first half of the book is talking about those concepts. All right, any more questions, just drop them in the chat. If you think of something later, just shoot me an email. Happy to have a conversation with you if you want to. If your company's, maybe you want to get a bunch of people together and ask me questions or go over something that was confusing, happy to do so on there. And then I'll make if you want to email me for the deck, I know there'll be a recording and then maybe you'll have the deck somewhere too, but you can also just email me for it and happy to give you that.
Yes.
All right.
Thanks a lot, James. It was an amazing session. So once we finish the session, tomorrow, all the attendees will be getting an email with the recorded session and the presentation deck.
Oh, good.
Yeah. Opening it up to the attendees to come off mute and ask any questions from our speaker.
People are quiet. That's okay. Like I said, if you want to just email me, if you have something you follow on to think about, if you get the deck and you go through and you're like, wait a minute, I don't understand what he was talking about, just shoot me an email.
Hey, James, I have a question. My name is Jeshnath, and I'm calling you from Seattle.
All right.
Hi. So you didn't mention Databricks. Is that, how do I read that?
You, if I go back to this one slide where I said that it's the great unifier here, this one, I have it where it's pointing to Data Lake Store Gen 2. You could have Databricks out here that's doing its thing and writing the data into the Data Lake Store Gen 2. And then Fabric can use that data without having to copy it over. It just creates a shortcut to it. I have whole conversations with customers, and I have other slides that talk about how you can use Fabric and Databricks together. It's never, hey, use Fabric and get rid of Databricks. It's use whatever product you like, use both products. Maybe Databricks is great for people that have some Spark knowledge and are more like hands-on coders, where other people are just report writers and they don't really get very deep in or code at all, and they want to use Fabric. Well, the data could be in one central location and both products can use it. So I can be in Databricks and writing that data. Fabric has a shortcut and pulls that data into the report. And if Databricks updates that data, that shortcut continues to pull the data in as needed, and there's not having to refresh the data or copy it over on that. So Databricks and Fabric together is a very popular story that we use. Same thing with Snowflake now. And so I can always go in deeper dive on that if you want, and if send me an email in there, but it's using both.
Perfect. Thank you. Thank you.
Yeah. I would say most customers I deal with, 75% are using Databricks and maybe 50% are using Snowflake. And so we always position Fabric as a additional product you can use if you have customers, maybe they're already using Power BI and you want to make it easier for them to use that data that is in Snowflake or Databricks was using. And Fabric can make that real easy. And maybe that'll save you some cost or save you some time on there, but it's not trying to displace Databricks or Snowflake.
Okay. And a follow-up question. So if you are proposing Fabric, do your customers then have to use Data Factory?
No, there's many different ways you can get data into OneLake, and I have a blog about that too. There's 7 or 8 different ways in there. Everywhere from using AZ copy to uploading it directly to using shortcuts to using mirroring on there. So the answer is you don't have to use Data Factory. That's just one of many options to get the data into OneLake.
Gotcha. Thank you.
Yeah. Okay. Awesome.
Yeah.
Well, again,
I
thanks
have a
everyone.
question.
Oh, you're sure.
Oh, sorry. Yeah, so I just because you talk about Fabric and for the generative AI and agentic AI, when we go to deployment for those applications, and how do you see Fabric actually could be a good deployment architecture for this application?
Yeah, a blog that I came out with today was how to make data AI ready. And because if I'm building an agent or using any kind of Gen AI application and it's going to use data, I have to be really certain that data is accurate and clean. It's the junk in, junk out. Gen AI has a bad enough problem with returning wrong answers, but now imagine you're using Gen AI to ask questions, English questions on top of data that's sitting in Fabric and that data is not joined or aggregated correctly or not cleaned correctly in there, it's gonna be really problematic for end users in there. So you got to get that data AI ready, and Fabric is that mechanism for taking that data, going through the layers, getting it all cleaned and aggregated and ready for that next layer that may be doing even more with the data to make it AI ready. That could be going in there and getting rid of acronyms and putting the full words in there. Anything that's going to make it easier for a Gen AI engine to understand that data better in there. So Fabric is frequently used by customers to get the data used by an agent. And Fabric has what's called a data agent built into it that allows you to create a bot that is going to ask questions on structured data sitting in a lakehouse or a warehouse, and also to train it, to give it hints, to have better answers into it. And that's unique because other products don't work on structured data. They work on semi-structured or unstructured data like text and documents on there. But so Fabric has that data agent, which they also announced it's going to also work on semi-structured and unstructured data. So now you can use data agent for all three, but you got to spend the time to do all the work to make that data AI ready. And that's if the same, if not more work that it takes to use the data on reports and dashboards. If you're going to use it on an AI, you got to go through all that same amount of work.
Thank you. Makes sense.
All right. Anything else? My voice is failing me, but I think I made it to the end.
We do have a comment about your book on the chat, James.
Oh, you read?
Yeah.
Oh, thanks.
Thanks,
Also
James.
a great
Yeah.
comment. Yeah.
Yeah. Amazing. If there aren't any questions, as James mentioned, feel free to reach out to him via email, you said, James? Am I right?
Yeah. Yeah. That's the
Yeah.
email I'll put at the bottom there. Just feel